All right, welcome to day 4. In your planners, you can be writing that packet page 30 is your homework for tonight. If you could also be taking out your homework from over the weekend and having your warm-up sheet out. Also in your planners, you can write you could be working on your problem set. Remember, this problem set will not be due till a week from Friday. Since I'm not here today, give you a little bit of extra time. So we're going to pause the video for 2 minutes. We're going to let you answer the warm-up and make sure you have your homework written in your planner for tonight. All right, so if you're looking to identify bias, we want to look and see, are there any groups that are over or underrepresented? Okay, so you want to look to see if any groups are over or underrepresented. Okay, so overrepresented would be the way you're collecting your data. Does it cause only one type of person to give responses? Does it exclude other people? That would create bias. Usually on the Regents, it's a multiple choice, and you just can think through and reason through it, and it's usually pretty obvious which one would exhibit bias. Alrighty, so on the homework, the first one, she's doing every 8th chip. Anytime there's a pattern that you're doing over and over again, that's considered a systematic sample. In 2, first they were divided up into low, middle, and upper income, and then taking a random sample. So when you split into groups first, and then take a random sample, that's stratified random sample. 3, we're just randomly selected from everyone, so that's a simple random sample. 4, since they're asking you to call in, that's a voluntary response sample. Usually those create a lot of bias. And a convenience sample because they're doing what's easiest for the person that is taking the sample for the last one. So we want to always try and be as random as possible, have the biggest sample size, and also not exclude any people. So in D, by selecting the grocery store, everyone's got to buy food at some point. So pretty much everyone should have a chance to be selected for this survey. So that's why that would be best. And in 7, only the people at the library are being picked, so that would be location bias. People outside the library are not having a chance to be surveyed, so that's why that would be biased. All right, so for today's material, we're going to start on page 22, so we'll give you a minute to turn there. So an experiment is when we do something to people, animals, objects to try and observe a response. We talked about the other day an experimental design causes a treatment on some group. So maybe you have a control group and maybe you have something where you impose a treatment and you want to see what is the results of those outcomes. Our whole idea with the experiment is we want to reveal some response to the changes. So when you impose the treatment, does it elicit any response from your subjects that you're working with? So we consider the individuals that the experiment's on to be the experimental units, and we call them subjects. The treatment is the thing that we do to them. So maybe you introduce a new pharmaceutical. That would be the treatment. The control is where no treatment is administered. And then the response variable is what you're trying to predict. So if you give a new pharmaceutical, is there some disease that you're trying to reduce the effects of or something? That would be the response variable. And then a factor explains or influences changes in the response variable. So what things cause those changes to happen that you're trying to change? All right, So there are 3 steps when describing the design of an experiment. First thing we always do is we split into 2 random groups. Now it is important that you use the word random when you say you are describing your groups, because if the groups aren't random, then the experiment is not designed well. Then in the second step, one group is given the thing you're trying to test. So in this case, the rats are given the new diet. The other one is the control. Okay, nothing different. And then at the end, you have to compare whatever you're trying to affect. So you're comparing your results. So those are the 3 steps that we will always have. So down on the bottom of page 23, we're going to practice writing that out. Often this is a free response question on the Regents where you have to describe the design of the experiment. So we've got a new drug is developed. We want to describe a controlled experiment that can be created to examine the effect of the new drug. Well, it's always a 3-step description. So step 1, we want to randomly split individuals into 2 groups. And it is important that you have that word randomly. Okay, if you did not have randomly, it would not be considered correct. They need to be randomly split into 2 groups. Because if you just said split yourself into 2 groups, the people you might have like a bunch of friends go in one group, another bunch of friends in the other group, and being in that group of friends could cause them to be one way or the other. So they need to be randomly split into the groups. Number 2, we will always give one group the thing we're trying to test, and the other we would not give. So we will give one group the new drug, and do not give it to the second group. Now, often in drug testing, they will give that second group, the one that's not getting the drug, they'll give them what's called a placebo. So the groups don't really know if they're getting the drug or not. One is getting the drug, and the other is usually like a sugar pill that doesn't actually have any medication in it, because they found that mentally people will say they maybe feel better if they think they're actually getting the drug. So they have everyone take something, but just one of them is not actually the drug. And then your third step is always compare the results. So again, these are our 3 steps when designing an experiment. Randomly split individuals into 2 groups. Give one group the new drug and do not give it to the second group. And then we're going to compare the results. All right, so on the next page on 24, an agricultural department is developing a new variety of corn with an altered amino acid content that may have a higher nutritional value than standard corn. Researchers want to know if the new type of corn will help baby chicks gain weight. Describe a controlled experiment that can be conducted. Okay, so very similar to what we just did. We're going to pause the video for a few minutes and we're going to see if you can do your 3-step description just like we did on the last one. If you're stuck, look back to the description we just did on the previous one. Okay, so we're working with baby chicks here, so we want to randomly split baby chicks into 2 groups. Okay, again, if you didn't write that word randomly, what you have would be incorrect. So make any corrections on your paper that you need to as we're going through this. Give one group the new corn, and the other group standard corn. And then step 3, we always do compare the results. Okay, and that would be our design of an experiment. So that's it for our first topic for today, designing an experiment. Next, we're going to start looking at probability. So the probability of an outcome is how likely you would expect it to occur, and it is theoretically what would happen if you did it a large number of times. So for example, if you flipped a coin 10 times, theoretically we would say there should be 5 heads out of 10. Okay, but that might not happen because it's such a small sample. But if we did it a million times, you're likely to get pretty close to that 50%. Now, a probability can be given as a fraction, a decimal, a percent. So like the probability of flipping a coin and getting a head, you could say is 1/2, you could say is 50%, or you could say is 0.5. Fractions are the most common way that we will do it because the decimals and percents sometimes will not come out nice, but always just look in the direction. Sometimes they might have you round to one of those. So again, the probability is what would happen in the long run if we did lots of trials. So here's an example of if you flip a coin, the red and the blue, or the dotted, are 2 separate tests. Well, notice early on, there's great variation in them. But as you go far down the line, as you get to 5,000 tests, both cases, the proportion of heads was pretty close to 0.5 or 50-50. So the probability is just what happens in the long run. So next on the bottom of page 25 is sample space. So sample space is all the possible outcomes you could get. So if you flip 2 coins, you could get HH for head and a head, head and a tail, tail and a head, or tail and a tail. Those are our different options. If we rolled 2 dice, you have options of 1 through 6. So you could have a 1 and a 1, could have 1 and 2, 1 and 3, 1 and 4, 1 and 5, 1 and 6. And then we could have 2 on the first die and 1 on the second one. 2 on both, 2 and 3, 2 and 4, 2 and 5, 2 and 6. And then we could keep going. Now what's nice about the sample space is seeing the sample space visually can often make it easier to identify what your probability is. Now some of the questions we'll see on homework that work with 2 die or 2 dice, I will give you this sample space written out because as you can see, it's kind of a pain to write out the whole thing. Okay, so be on the lookout for that in homework problems in your packet. But for this, we'll write out all of them. So essentially the first number is saying what we get on the first die, and the second number is what we get on the second die. Well, something that's kind of neat about this setup is the diagonals all have the same sum. So if you wanted to see which sets of dice added to 9, let's say, notice this diagonal is where they all add to 9. If you wanted to know ones that added to 4, notice this diagonal, they all add to 4. So when you're looking for sums of the 2 numbers on the die, the diagonals are where you would want to look. So that's just something to note. Every probability ranges from 0 to 1. 0 would be if there's no chance for it to occur. 1 would be if it is definitely going to happen. And then the probabilities could be anything in between. But you should never get a probability that is a negative, and you should never get a probability that is bigger than 1. So on the bottom of page 26, we've got the complement. So the complement is basically what is left over to get you to 1. So for example, let's say that event A was getting, let's say probability of less than 3. Okay, when you see this notation, P and then something in parentheses, the P just stands for probability, and you're finding the probability of what is in the parentheses. So our numbers that are less than 3 are the 1 and the 2. So the probability of this event would be 2 out of 6. Now, probability is one of the few things where you don't often reduce. You can reduce it and say it's 1/3 if you want, but you don't have to. Your complement is the opposite of that. So our complement of this would be things that are not less than 3. So that would be 4 out of 6. Notice we could have gotten that by doing 1 minus 2, 6, because 1 is 6, 6, and that would give us the 4, 6. So example, if the probability of thing A was equal to 2/3, its complement would then be 1/3. So it's what's left over, basically, so that the numerators will add together to give you what the denominator is. So to practice that, and I had one typo on here. This should say like a C there, so that means for the complement of A. So if A is Monday, Thursday, and Saturday, the complement of A, and again, this is on the top of page 27, the complement of A would be the ones that are left over. So we would have Tuesday, Wednesday, Friday, and Sunday. So at least 2 people selected out of 5. Well, at least 2 people means you could have 2, 3, 4, or 5. So the complement of that would be saying less than 2 people selected. Okay, so it's always just the opposite of what you have. And the complement of C, no one is selected out of a group of 4. Well, your options of being selected are 0, 1, 2, 3, 4. This is what we have, so the opposite of no one being selected would be at least 1 person selected. So we would say at least 1 person selected. Okay, so complement is just the opposite. All right, down at the bottom, we'll start looking at some probabilities. Let's say we have a bag of M&Ms, and the probability of each color is given there, but we don't know the probability of blue. Well, all together, if you add up all of your individual probabilities, they should always equal 1. So imagine we called this X. We didn't know it. Well, we know that 0.3 plus 0.2 plus 0.2 plus 0.1 plus 0.1 plus X should equal 1. Okay, because all of the possibilities added up should equal 1, because that's a certainty. So 0.3 and 0.2 is 0.5, 0.2 more is 0.7, 0.8, and then 0.9. So this is really 0.9 plus X equals 1. So if we subtract the 0.9 over, that really means X, our probability of the blue, is just 0.1. Okay, and we're getting that because we know each of the individual probabilities should add to 1. So now what is the probability that a random M&M is red, yellow, or orange? When you have an or, you're adding them up. So here's our red, here's our yellow, here's our orange. If we added up 0.2, 0.2, and 0.1, that would give us 0.5 for the probability. They were given in decimals, so we just give our answer back in decimals as well. All right, so on the next page, since I'm not here to actually ask you these things, we're just going to skip down to the bottom to the notation. So an intersection of events are things that belong to both sets. So the example we were going to do in class is people who have brown hair and people who have blue eyes. So people who belong to the intersection would be the people who have both brown hair and blue eyes. Our notation, we either write and or we see this symbol here. Now, I always think of it as that little thing kind of looks like close to how some people draw their capital A's, and that's how I remember that that's the and symbol. So that's saying A or B, and that's representing the intersection. So the intersection is the overlap of the two groups. Now, down on the bottom, we have the or. So the or is called the union, and that's anyone that is in set A or set B, or they could be in both. The symbol for the union is the U, and again, that means or. So if we go to the next page, we have a Venn diagram here. We're going to say the circle on the left is people who like to text, the right is people who like to draw. So this section here would be anyone that likes to do both things. This section here would be people who like to draw but do not like to text. This section here would be people who like to text but do not like to draw. And lastly, anyone that's on the outside are people that do not like to do either of them. Okay, so that's the design of a Venn diagram, what each of the things represent. So what we're going to have you try, we're going to give you maybe a minute to do this. See if you can shade in the three diagrams on the bottom what is represented by each of those. Where would you shade for the union? Where would you shade for the complement of A? And where would you shade for the intersection of A? And we'll give you 1 minute to try and do that. So this is our or. This is our union of A or B. So we should shade any spots that are in either section A or in section B, or it could be in both. So we want to shade all of this, including the middle, and all of that. Okay, that would be what's represented by the or, the A or B. Let's go down next. The intersection, that is where we are parts of both A and B at the same time. So you should just have that part shaded. And the last, the complement of A, well, that's anything that's not in A. So that would include this part, but then it would also include the outside part. Those would represent the spots that are not in A. The complement of A means the opposite of A. All right, in the time remaining in class, you can start your homework. If you finish your homework, then you can be working on your problem set as well. Have a great rest of your day, and I'll see you tomorrow.